Have you ever noticed how, like, when you run into something totally new, your brain just automatically tries to figure it out
Hmm.
by connecting it to something you already get?
Yeah.
For folks who lean philosophical, like yourself, that whole process of making analogies, it's not just some handy trick, right? It's kind of like built into how we make sense of
That
things.
really is fundamental, yeah.
Yeah.
And today we're diving deep right into analogy, analogical reasoning, the whole nine yards. It's
Yeah.
not just for everyday life, this way of thinking. It's had a huge impact on scientific discoveries, philosophical arguments. Heck, even legal precedents are based on it.
For sure. And to help us navigate this whole thing, we're mainly using the Stanford Encyclopedia of Philosophy. It's like this incredible resource that shows how seriously philosophers take these core concepts and their take on analogies. Super thorough, as you'd expect.
And for anyone who's into philosophical thinking, really getting analogy, all its little twists and turns, it's super rewarding. It helps us think more critically about not just our own reasoning, but the arguments we hear all over the place. It pushes us past simple comparisons to see the deeper stuff, the potential problems when we draw those parallels.
Totally. So, what we're aiming for in this deep dive is to really unpack the philosophical insights about analogy. We want to give you a clear overview, but keep it engaging, hitting the key points philosophers have found really important, but without getting bogged down in too much detail. Think of it like a targeted exploration, helping you sharpen your understanding of this essential way of thinking.
Let's start with the basics then. What exactly is an analogy, and how does that analogical reasoning thing actually work?
Right, right. At its heart, an analogy is like a comparison, right? It highlights the ways two different things are similar. It could be objects, ideas, systems, whatever. And then analogical reasoning, that's when you use those similarities to figure something else out. When that figuring out is structured to support a conclusion, bam, that's an analogical argument.
Let's say you're looking at two political systems,
Right.
and they both have, like, separation of powers, regular elections, that kind of thing. Now, one of these systems seems to lead to economic stability. So you might reason, because of these shared features, hey, the other system, it's probably going to help with economic stability too.
So in this example, the separation of powers, the elections, those are the basis of the comparison. And then the economic stability, that's what we're trying to infer. Now, the Stanford Encyclopedia folks, they mention these arguments are usually ampliative. What does that mean, especially for a philosopher trying to make sense of these arguments?
Okay, so ampliative, it basically means the conclusion you get from an analogical argument. It's not a slam dunk. Unlike deductive arguments where the conclusion's got to be true if the premises are true, here, the conclusion goes beyond what's strictly in the premises. It's more like it offers a degree of probability or plausibility, and philosophers are still arguing about exactly how that works. And that's what makes evaluating these arguments so tricky and so interesting.
It's not like it's a brand new idea either, right? Philosophers have been wrestling with this stuff for ages.
Oh, absolutely. Using analogy to reason and persuade, that goes way, way back. You see it in early science, when people tried to understand the unknown by comparing it to what they knew. And in philosophy, of course, where analogies have been used to make tough ideas clearer, to build strong arguments in all sorts of areas, ethics, law, you name it.
So we've got analogies. As these comparisons, they drive analogical reasoning, which can then lead to full-blown arguments. But the Stanford Encyclopedia, it suggests that analogy does more than just build arguments.
Right. It's not all about justification. Analogy also plays this vital heuristic role. Basically, it helps with discovery, with coming up with new insights. Think of it like a spark plug for your brain. Joseph Priestley, pretty influential guy, he famously said, "Analogy is our best guide in all philosophical investigations."
Strong words. So by seeing similarities, we might stumble onto fresh ideas, potential solutions, things we wouldn't have thought of otherwise.
Precisely. When we hit a new problem or something we don't really get, our minds, they naturally look for parallels in what we do know. These analogies, they can hint at mechanisms, promising lines of inquiry, even completely different ways of framing the problem. And as the Stanford Encyclopedia points out, this is a big deal in AI research, where the goal is to make systems that can solve problems creatively, using analogy. And it's a recognized technique in philosophy itself, like in Hajeck's work.
It's like if you're trying to wrap your head around some new social behavior, right? You might compare it to something familiar, like how markets work, just to get some initial ideas going. But then there's that justificatory role we mentioned, using analogies to back up claims.
Right. And how strong that support is? Well, that can vary a lot. On one hand, you've got analogies that lead to what we might call strong predictions. The hydrodynamic analogies, those are a good example. Engineers, They can use the principles of how fluids work to model stresses in structures,
Yeah.
because the math behind them is really similar. And within the model, those inferences could be pretty solid.
So in those cases, the analogy, it's not just a suggestion, right? It gives you a good deal of confidence in what you're predicting, at least within that model.
Yeah, the shared mathematical structure, it lets you make a pretty strong inference. But then, in a lot of other cases, an analogy might just offer weaker support, maybe just establishing some plausibility, enough to make it worth exploring further. Think about Reed's argument about extraterrestrial life. He pointed out a bunch of similarities between Earth and other planets orbiting a star, atmospheres, cycles, and from that, he cautiously suggested that, hey, it's not unreasonable to think that other planets could have life too.
That's a much more careful conclusion, right? He's not saying aliens exist. It's more like, hey, it's a real possibility worth checking out.
Exactly. A lot of times, the main point of an analogical argument is to make an idea plausible enough to deserve more research. Darwin's analogy between artificial and natural selection, that's a perfect example. He compared how humans breed animals for specific traits to how nature might select organisms that have advantageous traits. That analogy was super important for introducing his theory. But even Darwin admitted, at first, it only gave a little bit of probability.
So it was like a crucial first step, to make a radical new idea more digestible, something people would take seriously.
Absolutely. And sometimes analogical reasoning might be the only way to justify a claim, especially when you're dealing with things you can't directly observe. The Stanford Encyclopedia talks about ethnographic analogy in archaeology. That's a prime example.
That's where archaeologists look at artifacts from old cultures, and they compare them to the tools and practices of people alive today with similar ways of life, right?
Right. So if they find tools that look a lot like tools used by living communities in comparable environments, they might think, hey, those ancient tools were probably used for similar things. Like they found markings on Moche clay pots in Peru that look like ownership marks used by potters today. When you don't have written records, analogy becomes this essential way to guess about past behaviors and beliefs, even in cosmology, for things we can't even see.
It's amazing how our understanding of today can give us a peek into the past, but it sounds like analogy can also shape the direction of research in a whole field, like what they call a programmatic or paradigmatic role in the Stanford Encyclopedia.
Definitely. You see, over time, some powerful analogies, they get embedded in how scientists or thinkers approach a problem. They influence what questions get asked, what methods are used, even the whole framework for interpreting results. Like, take the acoustical analogy in 19th century physics. Physicists saw this strong parallel between the specific colors emitted by atoms and the frequencies of sounds from vibrating strings or tuning forks.
So it wasn't just about a few isolated ideas. This analogy, it drove a whole research program trying to understand how matter is structured using the idea of vibrations.
Exactly. But the Stanford Encyclopedia makes a good point. These guiding analogies, they can also create blind spots. If the real world doesn't quite match the analogy, researchers might go down the wrong path or miss crucial stuff that doesn't fit. The whole quantum theory thing, that showed the limits of the acoustical analogy. It proves a dominant analogy can be replaced when we understand things better. That's why it's always important to think critically about the scope and limits of any analogy we're using.
Yeah, it reminds us that analogy can be super useful, but we've got to watch out, it can mislead us too. Oh, and the Stanford Encyclopedia briefly mentions analogical cognition as something broader than just reasoning. How's that different from what we've been talking about?
So analogical cognition, that's like the whole shebang, all the mental processes involved in seeing analogies, building them, using them. It's a big research area in cognitive science. They're looking not just at the logic of analogical arguments, but at the mental mechanisms that let us see similarities, connect things across different areas, and apply those insights to problem solving and learning. Our focus here, like they say in the Stanford Encyclopedia, it's mainly on the philosophical analysis of the arguments themselves and how to evaluate them. All right, so we've got a good handle on what analogy is, how it works in our thinking. Now, let's dig into the structure of these arguments. The Stanford Encyclopedia gives us this basic format. Right, the basic way to represent an analogical argument is this. You start by showing that a source domain, S, and a target domain, T, have some stuff in common, properties, relations, Then you see that the source domain S has this other feature, Q. The analogical leap then is to say that the target domain T probably has a similar feature.
Okay, so let's take an example that's relevant to philosophy. Like the analogy between the human mind and a computer back in the early days of cognitive science. The mind S and the computer T both process information and have some kind of memory. The early folks, they noticed that computers S have internal representations, Q. So they figured the human mind T, it must have internal representations too, Q.
Exactly. In that case, the shared information processing and memory, that's the positive analogy, and the existence of those internal representations, that's the hypothetical analogy they're arguing for. And the Stanford Encyclopedia emphasizes that an analogy, it's about mapping the elements and relationships between the two domains. It's not about matching up every single thing. It's about focusing on what's relevant to the inference.
Then they talk about Hess's tabular representation. What's the advantage of seeing an analogy this way?
Hesse's table. It gives you a structured way to break down the analogy. You arrange the matching elements and relationships from both domains side by side. It lets you see the horizontal relations, the similarities and differences between the domains and the vertical relations, how things connect within each domain leading up to the feature you're inferring.
And they used Reed's argument about life on other planets to illustrate this, right?
Yeah, in that table you'd have Earth in one column, another planet like Mars in the other. The shared stuff like orbiting a star, atmosphere, those are the horizontal similarities. Life on Earth, that'd be a vertical relation in Earth's column. Then, the argument suggests that similar vertical relations might be happening on Mars, leading to the possibility of life there.
That definitely makes the structure clearer. It's not just listing similarities, it's about how they fit within each domain's bigger picture. Then the Stanford Encyclopedia brings in Keynes's terminology, positive, negative, neutral analogy. How do those distinctions help us understand this better?
Keynes' terms, they give us a more precise way to dissect the analogy. Positive analogy is all the confirmed similarities, the stuff we know both domains have in common. Negative analogy is the known differences, stuff that's true for one but not the other. Neutral analogy is the stuff we know about the source, but we don't know yet if the target has a counterpart. And the hypothetical analogy, that's the specific claim about the target that we're trying to support, the thing we're inferring.
And this all leads to the augmented tabular representation, right? Combining all these distinctions.
Exactly. The augmented table, it brings all these categories in so you can analyze things in more detail. You see the common ground, the potential problems from the negative analogy, and the specific point of inference. How strong the whole argument is then, it depends on how much positive analogy you have, how relevant it is, and how much the negative analogy might weaken the plausibility of what you're trying to infer.
And they stress that plausible here, it's a broad term. Any level of support, as long as it's not that deductive certainty.
Right, because these analogical arguments, they're inherently ampliative. The goal is usually to establish a decent amount of initial support, enough plausibility to say, hey, this is worth looking into.
Okay, so we've got this framework for dissecting these arguments, but then the Stanford Encyclopedia hits us with this question. Analogical inference rules,
Yeah.
with a question mark. Sounds like there's a big problem with formalizing this kind of reasoning.
You nailed it. That's a central issue in the philosophy of analogy. People use analogical arguments everywhere, but philosophers haven't found a universal set of rules that say for sure when an analogy is valid or strong. Not like with deductive reasoning, or even some types of inductive reasoning. There's no simple rule that says if A is like B and A has C, then B must have C that works all the time.
That's surprising, right? Given how much we rely on analogy in everyday life and in more formal thinking, they even try out a rule based on balancing positive and negative analogy, but then they immediately shoot it down.
Yeah, a basic rule might say more similarities, good, more differences, bad, right? But as the Stanford Encyclopedia points out, that kind of rule lets too much through. Just having shared features, even a bunch of them, doesn't guarantee that another property will carry over, especially if those shared features aren't related to the property you're inferring.
That example with the swan and a line segment, that really shows the problem of relevance. They both have some formal properties in common, like being reflexive, symmetric, transitive, but that doesn't mean we can infer they have concrete properties in common.
Right. The similarities there are totally superficial. They don't mean anything for any real inference you'd want to make. A good rule for analogical inference, it would need to have a solid idea of relevance built in. And that often depends on the specific context, on what we already know about the things we're comparing. A simple one-size-fits-all rule, that seems like a pipe dream.
The Stanford Encyclopedia touches on some more formal approaches, like that Carnapian inductive logic and Norton's material theory, which seems kind of skeptical of the whole idea of universal rules for analogy.
Some folks, They've tried to make analogical reasoning fit into the world of inductive logic, assigning probabilities based on shared properties. But that gets super complicated. It doesn't capture how nuanced and context-dependent real-world analogy is. Norton, he's different. He says the strength of an analogy isn't from some big universal logic, but from local, specific facts of analogy that justify the transfer of properties from the source to the target.
So instead of hunting for this one perfect rule, we should focus on the specific relationship between the source and target in each case. Which brings us to the next big topic. How do we actually evaluate how strong an analogy is, how plausible it is?
Exactly. If there's no definitive rulebook, we need other ways to tell if an analogy gives us good reasons to believe its conclusion. The Stanford Encyclopedia starts by listing some common sense guidelines, the kind you see in intro discussions of analogies.
There's those intuitive ones, right? Like more similarities is better, more differences worse, analogies about stuff we don't know much about are weaker, that sort of thing.
Yeah, they include things like how many similarities and differences are there? How much do we not know about the things we're comparing? How strong is the conclusion? Is it about causes and structure or just superficial stuff? How relevant are the similarities? And are there multiple analogies pointing to the same conclusion?
They sound pretty reasonable at first, but the Stanford Encyclopedia also says they're kind of vague and sometimes they contradict each other.
That's a big limitation. How do you measure more or fewer similarities? How do you tell a superficial similarity from a structural one? And relevance, that's still a tough nut to crack. They bring up that Reed example about extraterrestrial life again. Stebbing thought it was plausible because the conclusion was cautious. Mill dismissed it because we know so little about other planets. These guidelines, they're a good starting point, but they're not precise enough for serious philosophical analysis. Plus, they often assume that plausibility is all about probabilities.
So, for philosophical evaluation, we need better tools. The next section looks at Aristotle's theory of analogy. I was surprised to learn that he didn't talk about it exactly the way we do now.
Yeah, that's right. Aristotle used the word analogy, but he was mainly focused on two related arguments. The argument from example, paradigma, and the argument from likeness, homoiotes.
That paradigma thing, it sounds like you take a single instance, generalize from it, and then apply that generalization to a new case. Kind of deductive.
You got it. It's like a limited form of induction, then deduction. Aristotle's example, he said the war between the Thebans and Phocians was bad, so war against the Thebans is bad too. The one example of conflict gets turned into a principle, which is then applied to a new, similar situation.
But the Stanford Encyclopedia mentions another way to look at it, where it's actually fully deductive with a hidden general premise. Yeah. And that makes the specific example, the analogy, less important.
Exactly. If you just assume that war between neighbors is always bad, the argument works deductively. But the link between those specific examples, it doesn't matter as much logically.
Now, the argument from likeness, homoiotes, that seems closer to how we understand analogy today.
Yeah, with homoiotes, you draw inferences based on similarities, but without needing a universal rule. Yeah. It's more like, these things are alike in some ways, so maybe they're alike in other ways too, without saying they have to be. Like when Aristotle talked about how knowledge and ignorance work similarly and how we perceive opposites.
And the Stanford Encyclopedia says Aristotle often looked for underlying principles, often about causes, to make these arguments from likeness stronger, like how saltiness is a common factor for both seawater and sweat.
That's key. Aristotle seemed to think the best analogies were the ones where the similarities had a deeper reason. His criteria for homoiotes, they were: how many similarities are there? What kind of similarities are they? Identical properties, relations, etc. Do they come from shared causes or laws? And do you need to already know a general rule for the argument to work? He focused on overall similarity, especially those horizontal relationships, like Hume did later on.
Okay, so Aristotle gives us some historical context. Let's move on to Hesse's material criteria for evaluating scientific analogies. What's her main point?
Hess, she zeroes in on scientific analogies specifically. She says for a good scientific analogy, you need three things. First, the requirement of material analogy. This means the source and target have to be similar in observable ways. It's not just about matching theories or mathematical structures. That's formal analogy.
So for Hess, the analogy has to be rooted in real empirical similarities, not just abstract theoretical stuff.
That's her initial idea, yeah. She sees material analogies as pre-theoretic, often using metaphors from how we experience the world. But the Stanford Encyclopedia points out that formal analogies have been super important in math and physics.
Like the analogy between light and waves, right? That's based on the math, even though light isn't actually like water waves. Well, what are her other criteria?
Her second one is the causal condition. She says, for a strong scientific analogy, the connections in the source domain between the similarities in the thing you're inferring, they should ideally be cause and effect relationships. The idea is you're transferring causal knowledge from the source to the target.
But the Stanford Encyclopedia pushes back a bit, saying this might be too strict. It could rule out good analogies based on strong correlations, even if we don't fully understand the cause, like Franklin's analogy between lightning and electricity.
Exactly. Sometimes a strong pattern is enough for an inference, even if we don't have the whole causal story figured out. Then, Hesse's last condition is the no essential difference condition. This one says that the essential properties or causal relations of the source shouldn't be part of the negative analogy, the differences.
That makes sense intuitively. Don't base an inference on something that's fundamentally different from the target, especially if those differences could affect the property you're interested in.
Right. But the Stanford Encyclopedia points out that Hesse doesn't define essential very clearly, so it's hard to apply this rule consistently. Plus, it won't make us reject useful analogies if we get hung up on some supposed essential difference. Like a rectangle and a box, they're different in a pretty fundamental way, but you can still make good analogies between their geometric properties. But even with these criticisms, they acknowledge that Hesse's criteria were a step forward. She emphasized how important it is to understand the specific domains, and she focused on the modal plausibility of the inference.
Okay, so Hess was all about the material stuff and causes. Now we've got formal criteria and the structure mapping theory. Seems like a shift in focus.
It is. Structuralist approaches, like Gentner's structure mapping theory, they say what matters most is how similar the structures are between the two domains, like the patterns of relationships. It's not so much about the specific features of the things themselves. The main idea is an analogy is about mapping relations from the source to the target.
And Gentner's theory, especially how it's used in that structure mapping engine, SME, it really focuses on systematicity.
Yeah. Gentner says how good an analogy is depends mainly on how systematic the mapping is. Systematicity means how much do the mapped relations in the source form a coherent, interconnected system, especially involving higher-order relations between relations. The systematicity principle says that mappings that preserve bigger, more interconnected structures, those are better.
So it's not just about having more similar features, it's about them fitting together in a meaningful way, both in the source and the target.
That's the core of the structure mapping theory. But the Stanford Encyclopedia raises some good challenges to this purely structural view. First, they point out that in some types of analogy, like those ethnographic analogies, the surface-level features, those material analogies Hess talked about, they can be really important. And second, and this is maybe more important, systematicity might be a good sign of a strong analogy, but it's not the only thing that matters.
Like that example comparing Antarctica today to ancient Mars versus Antarctica to Mars today. The analogy between Antarctica and Mars today might have more structural systematicity, but the analogy with ancient Mars, when it might have had liquid water, that could be more plausible for thinking about past life, even if the structural parallels aren't as extensive.
Exactly. More systematicity doesn't always mean more plausibility or a stronger inference. Plus, sometimes, especially with causal reasoning, too much systematicity can actually weaken the argument. They also bring up Schlimm's critique from mathematical analogy. He says that in domains with tons of objects but not many relations, systematicity becomes meaningless. It can't tell good analogies from bad ones.
So while the structure mapping theory gives us some good insights into how relational similarity works, it seems like a purely formal approach has its limits too. What other ways of evaluating analogies does the Stanford Encyclopedia explore?
Next up, they look at other theories, starting with connectionist models from cognitive science. These models, like Holyoake and Thagard's multi-constraint theory, which is used in a program called ACME, and Hofstadter and Mitchell's copycat program, they're more focused on the mental processes behind analogy. Things like retrieval, mapping, transfer, learning. They're not so much about making abstract criteria for evaluation.
So these models are saying that maybe analogy is more about how different cognitive factors interact rather than following strict logical rules.
Yeah, that's the idea. Holyoake and Thagard's multi-constraint theory says that making analogies is driven by satisfying multiple constraints at the same time, structural, semantic, similarity of concepts, and pragmatic relevance to your goals. And copycat, that explores how analogies are perceived and develop in a dynamic system, highlighting how fluid and context-dependent analogical reasoning is. These connectionist approaches, they challenge the idea that we need explicit rules to judge analogies. They suggest that good analogies come from the interplay of different cognitive pressures. But the Stanford Encyclopedia also argues that we still need those normative philosophical principles, especially when we're critically evaluating big analogical arguments in academia and science.
Then they bring up Bartha's articulation model. How's that different from the structural and connectionist views?
Bartha's model, it shifts the focus away from horizontal similarity, the stuff between the two domains, and onto the vertical relations within each domain. How the known positive analogy connects to the hypothetical analogy. He says a strong analogical argument needs two things: prior association and potential for generalization.
Prior association means there needs to be a clear, well-understood connection in the source domain between the shared features and the feature you're inferring, so you can pinpoint what's crucial in the source.
Exactly. And potential for generalization means there should be a good reason to think that a similar connection could exist in the target domain, and there shouldn't be any major differences that would mess that up. Bartha stresses that you need to spell out the prior association in the source. Is it causal, mathematical, functional, whatever? Then you carefully check if that association is likely to hold in the target, considering any key differences. That rectangle box example comes up again to show how analyzing the proof or reasoning in the source can be super important for evaluating the analogy.
So it's not just about superficial similarities or abstract structures, but about understanding why the source has that property and if those reasons probably apply to the target too. And lastly, the Stanford Encyclopedia talks about practice-based approaches to evaluating analogies.
Right. These look at how analogy is actually used and judged in specific fields. Norton's material theory comes up again, emphasizing that the justification for an analogy comes from domain-specific facts, not universal rules. They use that Galileo's moon-mountains analogy. The inference that the moon has similar surface features, it's based on our knowledge of geological processes on celestial bodies.
Yeah.
But they say this theory might not help much when you're dealing with analogies where the nature of the target system or the underlying similarities are what's being debated.
Then there's the idea that different fields might have their own working logics, their own sets of criteria for judging analogies, tailored to their subject matter and methods.
Exactly. Philosophers of science, especially in archaeology, they've looked at the specific challenges and criteria for using ethnographic analogies to understand past cultures. Considering things like how stable cultural practices are and the ecological context. And there's this idea of robustness reasoning, where multiple lines of evidence, including analogies, all point to the same conclusion.
And finally, they touch on formal analogies in physics. That's the idea of Pythagorean analogies, where the similarity is purely mathematical, even without a clear physical basis.
Steiner's concept that challenges the traditional view that good scientific inferences need some kind of physical resemblance. Like Schrödinger's relativistic wave equation, it was partly inspired by formal mathematical analogies. Some philosophers are still iffy about inferences based purely on math, but others say they can be surprisingly useful for coming up with new theories in physics, like Fraser talked about with CSM-QFT and renormalization group methods.
Wow, we've covered a lot. Different ways philosophers have approached evaluating analogical arguments. Now let's get to the philosophical foundations, the attempts to justify why we should even trust analogical reasoning in the first place.
Yeah, now we're asking the big question. What makes us think analogy is a valid, reliable way to figure things out? The Stanford Encyclopedia points out this tension. We use analogies all the time, but lots of analogical arguments are clearly bad. Justifying analogy is tied up with figuring out what makes a good analogy in the first place.
The first approach they discuss is deductive justification, trying to show that analogy is just deduction in disguise. We talked about Aristotle's paradigma here.
Right. The idea is to find a general principle that, when you add it to the premises of the analogy, turns it into a deductively valid argument. But, like we said before, this often makes the specific analogy itself less important to the logic of the argument.
Then there's determination rules, where you say there's this unspoken premise that the property you're inferring is determined by the shared properties.
That was Davies and Russell's idea. If we have reason to believe the shared properties mean the inferred property has to be there, then the argument becomes deductive, like that used car value example. But the Stanford Encyclopedia says, in many real-world cases where we use analogies, especially when we don't know everything, we don't have those strong determination rules, so it's not really deductive.
So trying to force analogy into a deductive box, it doesn't really capture what it's about, especially when we're reasoning with incomplete information. Next up, Inductive justification.
Here, the goal is to connect analogical reasoning to how we do inductive inferences. One way is single-case induction, going back to Aristotle's paradigma. You generalize from one observed instance, the source domain, to a broader principle that applies to the target. They say in some very specific contexts, like Cartwright's work on stable natures or Quine's ideas about natural kinds, this kind of single-case induction might work. But they argue it's too limited to explain most analogical arguments.
And it doesn't help us figure out which similarities are relevant, which aren't. The second inductive approach is sampling arguments, building on ideas from Mill and Herod. They say the known similarities are like a sample of all the possible properties.
So if you see a lot of overlap in the known properties, you can guess inductively that they probably share other properties too. But the Stanford Encyclopedia points out two big problems. One, the counting problem. How do you define and count the relevant properties objectively? And two, the problem of bias. We don't know if the properties we know about are a random or representative sample.
Finally, under inductive justification, we've got the argument from past success. This tries to justify certain analogies, especially those Pythagorean ones in physics, by saying, hey, they've worked before.
That was Liston's suggestion. The argument is, if a certain kind of formal analogy has led to accurate predictions or new understanding in the past, we have an inductive reason to trust similar analogies in the future. But the Stanford Encyclopedia asks, how do you define a similar strategy without already knowing what makes an analogical argument successful?
So it seems like inductive justifications for analogy also have some serious issues. What about a priori justification? That's trying to base it on fundamental self-evident principles.
Right. Keynes's principle of the limitation of independent variety, LIV, that's one example. He said, if there's a limited number of independent factors that can vary across things, then seeing positive analogies makes it more logically probable that another analogy will hold. But, like Hess pointed out, there are problems with this. It relies on a type of probability that doesn't really account for learning from experience, and it can't tell the difference between strong and weak analogies.
Hess herself suggested the clustering postulate, using a Carnapian framework. That assumes there are underlying uniformities in nature, and it's biased towards generalizing.
Yeah, but they point out the usual criticisms of those uniformity postulates. They're kind of circular, and they can't tell good analogies from bad ones. Then there's Bartha's symmetry reasoning, another a priori approach. But it only works for arguments that fit his articulation model, and it only justifies initial plausibility. It uses Van Frassen's symmetry principle, which says essentially similar problems should have essentially similar solutions.
Yep.
Bartha argues that his model's criteria help establish that essential similarity, but there are still questions about how to interpret the symmetry principle.